Welcome to Omega Virtual Learning. This is your online math tutor. In this lesson, I will take you through derivation of the Pythagoras Theorem, how to use the theorem to work out the missing sides of right angle triangle given two sides, and also go through exam style problems. Now, Pythagoras Theorem is an equation that relates to the sides of a right angle triangle in a very unique way. What it says is this: the square of the longest side, normally called the hypotenuse, this is the longest side. The side facing the right angle is the hypotenuse. So the square on this hypotenuse is equal to the sum of squares of the other two sides. So the square on side A and the square on side B together must be equal to the square on side C. In short, this is what the theorem is all about. So using diagrams, if this side is A, square on side A, the area will be A squared, because A times A is A squared. Then on B, the side B, the area will be B squared. So we are saying that A squared and B squared should equal to the square on side C. Let's see. So to prove that I can make an area of A squared and B squared equal to C squared, I'm going to divide B squared into four identical right angle triangles. And I'm going to rearrange the four identical right angle triangles in the green to make a bigger square on C. So I'm going to move them one by one. First one, second one, the third, and the last. So now I can now put in my little square there, and it's true that this square represents C squared. As you can see, it represents C squared. So algebraically, it means that C squared, the area, is equal to A squared plus B squared. So that's what the theorem is all about. And this is normally used when you are looking for the longest side of the right angle triangle. If not, we use the subtraction rule for the other side. So if it is this side, it's C squared minus B squared to get A squared. Or if it is this side, C squared minus A squared. So actually what matters is that longest side, always use the addition rule. Any other side, subtraction rule. So let's look at simple exam question. We have the non-calculator method where you have to go through step by step, and the calculator method where you have to quickly use the calculator to get the answer. So here we call your formula longest side. So it means I'm going to square this side and add this to this side. That's the relationship. So x squared to replace c will be seen as 6 squared plus a squared. 6 squared means 6 times 6. A squared, 8 times 8. So be careful about that. Next line, work out these values. Next line, add these numbers. Next line, we are looking for x and not x squared. So you need to work out square root on both sides. And that will give you 10 cm. So x is 10 cm. When it's calculator method, just remember, because at the end we're going to find the square root and it's an addition rule, you just have to start with the square root and just do exactly what you would normally do. So you don't need to go through all these steps. So this is your A, this is your B. Square each of them and just put them under the square root. So you just hit the square root button, 2.4, then the x squared represents square. You hit the x squared, the square will come, plus 6.4, hit the square button, the square will come. Then you press the equal sign, and that will give you the answer. Make sure if you're using a bracket, close the bracket before you press the square button, and you get your answer as 6.84 meters when you approximate. Now let's look at what if it is not the longest side. Non-calculator method, the same way. So not the longest side is subtraction rule. So we start with the biggest number squared minus the other number squared. So y squared will be equal to 41 squared minus 40 squared. When it's non-calculator and the numbers are big, do side working by doing 41 times 41, 40 times 40 to get your answers before you continue. So next line, work this out. Next line, find square root on both sides. The square root will we'll cancel out the square. So y squared becomes y, and the square root of 81, that gives you 9c. Calculator method, you check it's not the longest side, so it's subtraction rule. So you start with the square root of c squared minus b squared. So if you remember, when we're doing this calculator method, we don't start with a square because we've taken care of it by using the square root sign straight away. When the calculator method, we start with the square onto the final one, you find the square root. So know the difference. So the longest side first, 9.8 squared minus 5.2 squared. Use the calculator, press the square root button first before 9.8 squared, then minus 5.2 squared. Equal sign, then you approximate accordingly. Sometimes you may be asked to find the length of a line segment. So for example, it's like this. You could either be just a straight line with the coordinates given, or just a line on a grid. They are all the same. So first here, work out your coordinates. So coordinate A is -4, -2. Coordinate B is 5 and 4. And note your x and y coordinate. Make a right angle triangle to connect AB. So it could be this way, or it could be the other way. Whichever way, doesn't matter. Now what is left is to work out the length of the vertical line and the horizontal line. To work out the vertical line, you look at the gap between the y coordinates. Horizontal line, look at the gap between the x coordinates. So let's look at the vertical line. Check the y coordinate. From -2 to 4, count -2 to 4. So -1, 0, 1, 2, 3, 4. 6 steps. Some people would like to do 4 minus -2, which will give you 6. If you don't want to get into the complication, just count. Horizontal line, we are looking for the gap between -4 to 5. So from -4 to 5, count -3, -2, and so on. You will know that the gap will be 9 steps. Then you have a simple Pythagoras question, right angle triangle. Obviously, this will always become the longest side. So this kind of question for line segment is always the addition rule. It's always the addition rule. So square root first, and square each number, add them, find the square root. That's 10.8. Second one, the same, right angle triangle. You draw a right angle triangle. Gap between the y from 3 to -4, or from -4 to 3. If you count, you will know it's 7 steps. Horizontal line, -1 to 11, -11, or -11 to 1. If you count, you see it's 10 steps. Hypotenuse, so it's addition rule. 10 squared plus 7 squared. Find the square root of that quickly. That'll give you 12.2. So that is how we use it to work out line segment. Now let's look at an exam style question. A builder places 2.9 meter ladder on a horizontal ground resting against a vertical wall. To be safe to use, the base of this ladder must be 1.3 meter away from the wall. How far up the wall does the ladder reach? Give your answer to 1 decimal place. This kind of question, you need to use diagram to represent it for you to understand what you are supposed to do. So this is the ground, level ground. This is the wall. The wall is definitely upright, so vertical. Now we've got the ground and the wall. We have a ladder, so this is the ladder. So that's the first thing you need to know. Now let's put in some numbers. It says the builder placed 2.9 meter ladder on horizontal ground. Okay, so 2.9 meter ladder, that's 2.9. Rest on the vertical wall. Okay, there's the wall. To be safe, the base of the ladder, this is the base of the ladder, must be 1.3 meter away from the wall. So this is the wall, this is the ladder. The gap between the foot of the ladder or the base and the wall must be 1.3. How far up the wall does the ladder reach? The ladder reaches this height. So we want to see the length from the bottom here to this point. So still Pythagoras, you check it's not the longest side, so it's a subtraction rule. So we just have to do a squared, whichever you remember, the recall of the formula. So a is now our x. So x is equal to 2.9 meters squared minus 1.3 meters squared. The calculator work it out for you, and it reaches 2.6 meters. So that's where the ladder reaches 2.6 meters. Simple. So that brings us to the end of lesson 1 on Pythagoras. Watch out for lesson 2 on Pythagoras, talking about Pythagoras in 3D. Pythagoras in 3D. Thank you very much. Share with your friends and subscribe to be alerted of new videos by hitting the notification button. Thank you very much.